Welcome to HDB Agronomy Week 2020. The live stream session will start shortly. Before we begin, we wanted to remind you of a few points of housekeeping. You're all on mute, so don't worry, we can't hear you. The session is scheduled to last between 1 and 1.5 hours, including questions. We want this session to be as interactive as possible, so please post your questions throughout the session using the live Q&A function in the Agronomy Week platform below. We're recording this session, so if you miss anything or would like to watch it again, it will be available on the HDB YouTube channel and HDB website. You can also come back and watch the recordings on the Agronomy Week platform for 3 months. At the end of the session, we'll provide you with unique BASIS and Naroso codes. Don't forget to complete the BASIS and Naroso forms using the relevant tabs on the platform. You have 2 weeks after the live session to register for your points. Join in the conversation online. Follow AHDB_cereals and AHDB_potatoes on Twitter. Use the hashtag AgronomyWeek. If you have any issues with the conference platform, there are digital event FAQs in the menu on the left-hand side. You can use the Help tab to contact the team if you experience any technical problems during the week. We hope that you enjoy Agronomy Week 2020. Thanks for joining us. Your session will now start.
Hello, my name is Alison and I'm a resource management scientist within the environment team at HDB. Welcome to the second webinar on the final day of Agronomy Week 2020. I'm very pleased to be joined today by Freya, Garry from the Met Office and Jamie Hannaford from the UK Centre for Ecology and Hydrology. Freya will be exploring how predictions of climate change in the UK may impact the occurrence of late blight using Hutton criteria and also the impact of drought and water availability. This then leads us on to Jamie's talk on the tools and resources available right now to support farmers with drought and river flow monitoring. We'll have both presentations and then we'll have some time for questions at the end. So please feel free to submit questions as we go along. Okay, I'll now hand over to Freya.
Thank you, Alice. So I'm going to start with an overview about our climate and how it's changing in the UK and how that affects potato growing, specifically looking at occurrences of blight and drought. So slides moving. So global temperatures have risen by about 1 degree C over the last 100 years or so. And the last 5 years, 2015 to 2019, are the warmest in records dating back to 1850. In fact, all of the UK's 10 warmest years on record have occurred since 2002. And in 2019, the highest UK winter temperature was recorded in February. And in July, the highest UK temperature ever was recorded. So the rate of warming that we're seeing is unprecedented in at least the last 2,000 years, and it's likely faster than any previous known warming event. So the climate is changing in other ways too. 5 of the 10 wettest years over the last 150 years have taken place in the last 20 years, with both slightly wetter summers and winters than we were seeing about 50 years ago. And you'll recall lots of named storms over the past few years, and disruptive rainfall from the 2015 winter storms was made at least 40% more likely due to climate change. So looking at our coasts as well, of course, mean sea level around the UK has risen by about 19 centimetres since the start of the 20th century. So heat waves like that of summer 2018 are now 30 times more likely to happen due to climate change than in the pre-industrial period. We know that this extreme weather is projected to continue to increase in the future with continued local and global emissions. So on average, over the future, there's going to be a greater chance of milder, wetter winters and hotter, drier summers in the UK. But this is against the background of variability. So each season is slightly different, which means we will still see seasons that buck these trends. The diagram on this slide shows when we predict to see 40 degrees Celsius in the UK. So over the past years, the chance of this has been very low. But as we move forward in time, we expect to see these 40 degrees Celsius events around every 1 in 10 years by the middle of the century, which is just 30 years away. And prolonged hot summers like that of 2018 may occur every other year. So we know climate change is here and will keep increasing. The vast majority of governments around the world, including the UK, have signed up to the Paris Agreement, aiming to limit temperature rise to well below 2 degrees and pursue efforts to limit that to 1 degree. The UK Committee for Climate Change is an independent body that's part of the legislative framework for tackling climate change under UK law. Part of their statutory remit is to report on the progress of UK government in tackling climate change risk mitigation, so less emissions, and adaptation. And the CCC, the Committee for Climate Change, say that if current trends continue, the average annual temperature in England may rise to 4 degrees Celsius or more. So there is a need to plan adaptation strategies for 2 to 4 degrees Celsius. And alongside a number of other sectors, the UK agricultural sector is not considered to be well prepared for climate change at this current time, and more action is needed to consider climate change impacts. So this meant that agriculture is featured in most of the priority areas for actions. So directly through domestic food production, through water shortages, imports, and trade and pests and diseases. And so the work here is filling that research gap partly. So I'm currently funded under the UK Strategic Priority Fund for Climate Resilience, which is an ongoing project across the UK, including a range of multi and interdisciplinary climate risk and adaptation research to build UK capacity for resilience to climate variability and change. And if you want to learn more about the programme, please visit ukclimateresilience.org. So I'm going to present some research from very recent state-of-the-art climate model projections of UK climate. And so if you work in this area at all, you might have heard these referred to UK climate projections or UK CP18. And the headline message of UK CP18 is that there is an increased chance of milder, wetter winters and hotter, drier summers, along with an increase in the frequency and intensity of extremes. So we run climate models on our supercomputer, and the models represent our best understanding of the whole weather and climate system. For weather or shorter term projections, so over the next couple of years, the chaotic nature of the atmosphere and oceans means that it's hard to predict. And so what we do is run the model many times to make a best prediction. On longer timescales, over decades, we know that we do not understand all the processes in the system perfectly, and we also don't know exactly how much emissions will be emitted. Despite this, over the last 20 years, climate models in general do a really good job at capturing the overall trend of warming. And the climate science communities are continually working to improve the models which make these long-term projections. And although I'm not going to talk about weather prediction today, it's worth noting that our weather forecasts are also getting ever better. So our 4-day forecast now is as accurate as the 1 day was 40 years ago, and increased computer capacity means we can update forecasts every hour to give even greater forecast accuracy. Sometimes it might seem a bit frustrating. We can't give an exact answer about decades in the future. And as I said before, the uncertainty around emissions is a big reason for that. In an ideal world, as on the left, we'd be able to give a high accuracy and high precision projection. But we know that if we give a really precise answer, then it may well not be accurate. So we give a broader range of possibilities, which may be less precise, but's more likely to be accurate. So given increased temperatures, but also short periods of high rainfall during summer, we wanted to look at how potato blight conditions were projected to change over the next decades. As you'll know, blight is typically mitigated against by the application of chemicals at great cost to the industry, and we wanted to see if that was likely to have to increase, and if so, where. We follow the thresholds used to predict outbreaks of blight from the operational service Blight Watch provided by the Met Office. We potentially underestimate the frequency of potato blight occurrences because our data is restricted to daily resolution, and we first assume the same threshold. However, I've looked at this in some detail, and although the numbers increase if you use a lower daily threshold, the amount of increase through time is similar in the regions where most potatoes are grown. We look at how often and how long blight events are in the model in the current climate and a climate of 30 to 50 years' time. So a few technical details about climate model. We're actually using a high emissions projection here, which is still plausible, though higher than current policies are aiming at. But it allows us to fill that advisory of the Committee for Climate Change that we should have planning for adaptation to 2 to 4 degrees over the rest of the century. Using the regional projections at 12-kilometre spatial resolution, we're able to look relatively local scale in the UK. We have 12 different projections with each version of the model using slightly different parameters, which are simply a way that we represent processes on scales smaller than the model grid resolution. They are all plausible but different, and this leads to different projections and encompasses some of the model uncertainty. But in the maps I'm going to show you over the next few slides, I'm just going to show you the mean of the projections. When we look across the whole UK at once, we can see that instances of potato blight, so we show here in days per year, are more likely to occur along the west coast, particularly in Wales and the southwest in the current climate. In the future period, blight conditions are more widespread across the west coast of Scotland and the northwest of England. Increases of up to around 2 weeks per year of blight conditions are possible in some of these western areas. However, most potatoes are not grown on the west coast. However, if you were thinking about expanding potato growing in some of the western areas, you should expect to see increases in blight conditions there, with the southwest really the only region in the UK where there's a decrease across the Devon area. So I just want to show how much that increase is going to change when you look at a slightly more near-term period. So in just 10 to 30 years is the left-hand panel, is the increase relative to the current period, then 20 to 40 years, and then the plot on the right is the same as in the previous slide. So you see there's that increase in intensity over time. It's a more linear trend. It's not going to be a big step change suddenly in 50 years' time. So the earlier you can prepare and help mitigate the effects of the increase, the better. So looking at the area, each area of the UK, we look at on average, the number of days that blight conditions are experienced, and I show that by an area of the circle. So if the circle is bigger, then the potato blight conditions are experienced more frequently. So the current climate here, you've got that hazard more often on the west coast. And then if I flick to the same diagram, but 30 to 50 years in the future, then what we see on average is how the area increases of the circle. So I've put that increase in each circle as well as a number. So you can see going between the two that the increases really are biggest in the north. And so in the future, if we're thinking of expanding potato growing in the north, Scotland, Northern Ireland, then you want to be prepared for some substantial increases in the number of potato blight occurrences. So I'm just going to show the same maps as before. Here's zoomed in on the key regions for potato growing. So here's the east of England, where potato blight conditions don't happen as often on the west coast, but there's still increases across the region and they're relatively smaller. So as a percentage increase, it's only about 20 to 30% on average across these regions. As we've said before, the increase is larger in the north, not so large across eastern Scotland as the west, though. And so the increases on average are nearly 70% across East Scotland. But depending on where you are exactly, it could be less, maybe as few as 1 to 2 days per year increase on coastal areas, for example. To show a bit more information about how long potato blight events might be, we can look at this here using the east of England as an example. So we show a box plot for each duration event. So just focusing on the left, we've events of 2 days or more long, and how many days on average there are of this type of event a year. So the blue box plots the current climate, the red box plots the future climate. The box plots shows the results from all 12 model projections. So the tails cover the lowest to the highest, and the main box is the interquartile range, and the cyan line in the middle is the median. So as we go to the right, the event's getting longer, 3 days or more, showing up to 7 days or more are here. And the key point is that the range shows that in the future periods, these longer events do get more likely. So something we're trying to do more and more is look at projections from a risk-based framework. So we're combining information about the hazard, so in this case warm and humid, with the vulnerability, which is the threshold exceeded, and the exposure, so where are the potatoes? And all together those that gives us the risk. So far the maps that we've shown so far include the hazard and vulnerability information. And so here's the numbers. So you know, the circle's bigger where the most potatoes are. I'll blend this information with the plots from before. So here we get an assessment of the risk in the current climate. So now the circles are biggest down the right-hand side because the potatoes are grown there. And if we assume the number of potatoes stay constant over time, then the risk will increase by the same amount as the hazard did before. So therefore we get something that looks like this. So depending on where you are, your risk might be high, but the projected increase quite low, so in the east of England, whereas high risk and high increase in parts of East Scotland, or lower risk and lower increase in the southwest or Wales, or lower risk but higher increase in West Scotland and Northern Ireland. So the picture is quite regionally varied, and so looking at the high resolution projections is also important for future planning. So I'll just wrap up talking about potato blight with a table here to show those figures for the increase by region listed in decreasing growing area of potatoes order. This infographic on the right-hand side highlights the increases that are projected across the 5 regions where most potato growing happens. So I'm going to talk a little bit about drought. I'm going to show how that's likely to change using information about rainfall deficits over time. So essentially we're looking at how different the future rainfall over a period of time is from the current climate rainfall. So where this drought severity index increases most, there may be more likely to be more severe droughts. But this doesn't include information about soil moisture in an area or whether groundwater may help to prevent drought. So the work of mine is, this work is showing here is actually by a colleague of mine, Helen Hanlon. So here we show this drought severity index at different warming levels. So 1 degree, 2 degree, 4 degree, and how this compares to the end of the last century. So shorter droughts, so 3 to 6 month droughts, are most severe down the east coast and across England. As the warming level gets more severe, so 2 degrees is reached about the same time as the future period I showed for Blight, this index intensifies. So we are expecting droughts to get worse along the east coast and across England than we do in the north and west. And so this is broadly a similar pattern to what we see for longer periods of drought, here 12 or 36-month long droughts. How the drought intensifies under climate change may be compounded in some areas with other pressures on the water sector, so increases to population, for example, which are projected to be greatest in the south of England. So the key messages are that although we expect heavy rainfall, we also expect more long, dry periods, leading to drier summer seasons overall and droughts. The droughts are not expected to become more severe in the north and west, but they are projected to intensify in the south and east UK. And the south of England is also where population is projected to increase most. So crops not resilient to water scarcity are even more likely to need irrigation, and this will be a key challenge for water companies to ensure they can deliver over the coming decades. So we have this situation where we're likely to have long dry periods and drought overall, but still intense short-term bursts of rainfall. So because drought is a longer timescale problem and blight is a shorter timescale one, we can see increases in both occurring in the future. So on the left panel, we show the magnitude of potato blight risk in each region using the circle area and how much it has increased from the baseline as a percentage. On the right, we show the 6-month drought severity index and how this is likely to change over a similar period. And together, these show that although increases in drought are low risk in most of Scotland, growers need to be prepared for large increases in blight conditions there. Lower blight increases in the southeast conflicts with increased likelihood of severe droughts, as well as higher urban demand for water, whereas the southwest might seem a better compromise between the two risks. So it'd be interesting to hear your thoughts on that. Something I just want to briefly mention before finishing is that several studies suggest irrigation can increase relative humidity locally, and therefore as the background climate is likely to increase, the propensity for blight conditions and then increasing irrigation that may be required for potato growing in some regions like the east of England could possibly exacerbate that. So in the literature, I mainly found studies in hotter, drier regions. So it'd be good to think about how this could change risk of UK potato blight as well. There may be people here who know a little more about that. So to conclude, the potato blight hazard is greatest along the west coast and will be in future with the largest increases in the north. So droughts are going to increase in severity most along the east of the UK and across England. And these risks can be mitigated against with spraying or irrigation or species selection as an adaptation route, or maybe both, depending on whether blight or drought or both are major concerns in your region. Maybe the region of the UK that potentially looks most encouraging for potato growth expansion, maybe the southwest. So please do contact me with any questions or queries in the future. My email's here. And this potato blight work is part of a journal paper that's going through review. So if you do get in touch, I'll be able to send you a copy when it's published. Thank you very much.
Brilliant. Thank you very much, Freya. I'm now going to hand over to Jamie Hannaford, who's going to talk about the recent advances in drought monitoring and also hydrological status monitoring. Okay, thanks.
Thank you very much. Thank you, Alice, and hopefully you can all hear me very well. So yes, my name is Jamie Hannaford. I'm the leader of the Hydrological Status and Outlooks Group at the UK Centre for Ecology and Hydrology. So my responsibility at CEH, I lead a team of scientists working on operational, seasonal hydrological forecasting, hydrological monitoring, and also the curation of all sorts of hydrological data sets. I'm going to be talking today about some of the advances in drought monitoring and early warning that we've been involved in over the last 5 years or so. I work on all aspects of the hydrological cycle, both extremes, floods to droughts. I'm focusing a bit more on drought today because we've been working on a lot of drought research in the recent past where much of this work has emerged from. But it's fair to say that actually much of this is really relevant across the whole range of the hydrological cycle, from wet to dry and all points in between. I'm also going to talk a bit about potential applications in agriculture, but I'll get my apologies in first. I'm not an agronomist, I am a hydrologist. And we provide all of these sorts of services for a very broad range of users. But more recently, we have been doing a lot of work with the agricultural sector and with farmers and growers. So I'm going to be talking about various applications that are useful for many end purposes, but with a focus towards the end on how these kind of things could be particularly useful for agriculture. Okay, so hopefully you've seen the slide move on. So just a bit of context. I wanted to start with a bit of an introduction about the issues around droughts and floods. But thankfully, I couldn't have asked for a better introduction, really, from Freya there, who's done a superb job of giving the context around how the UK's climate is changing and is set to change in future under anthropogenic global warming. I thought it's just worth pausing there and thinking about how this is, these are issues in the here and now. This picture is taken from early June, highlighting the sorts of challenges that were faced as a result of the exceptionally arid spring we had in the UK. I'm sure that needs no further introduction to many of you who are very much involved in managing that very hot and dry spell. But yeah, that period, along with other recent events such as heat waves in 2019 and of course the drought and heat wave in summer 2018, they underscore our continuing vulnerability to droughts in the UK, despite being overall a wet country. And of course, as we've heard from Freya, these both droughts and floods are expected to become more severe and more of a challenge for water managers in the future. So that's the kind of context. And as Freya has argued, we need to plan for this through long-term adaptation, but we also need tools in the here and now to actually manage these events. And that's what I'm going to be talking about, the kinds of things we can use to monitor how these events progress and actually decide what actions to take. Just to say as well, again, this is mainly focused on drought, but very relevant for floods. And I think this year highlighted once again the volatility we've seen in our weather. So the slide I just showed a moment ago was after the driest May on record, but we also had the wettest February on record. And again, I'm sure people were very aware the floods, which we saw, one of the most exceptional flood events in recent years, and there have been many. So we had this really major flooding in February, and then an incredibly an astonishing dry down to really dry conditions by the end of the spring. So this really highlights this volatility we've seen in the UK and how that's expected to change in future. So that's the kind of the backstory, and effectively we, in order to manage these extremes, we need data and we need observations, and this is very much what my work is all based on. Collating long-term observations of hydrological data sets, and I'm going to be talking about various of these as we go through this talk today. So we need river flows, we need groundwater levels, we need to understand soil moisture status, and we of course need all of the meteorological observations to support that. And as well as having the observations, we need methods for being able to tell people how, what those data are showing. Where are we, and how does that apply? What's the current status, and how does that fit into a hydrological in a long-term context? And that's what I'm going to be talking about today. I'm going to be talking about some new developments, but it's probably first worth pausing and saying actually there's a very long history of monitoring and early warning for droughts and floods in the UK. Some things like our hydrological summaries that we produce at CEH have been going since the 1980s. And the Environment Agency and the equivalents around the UK also produce water situation reports. There's also a hydrological outlook, so seasonal hydrological forecasts have been produced since 2013. So we're actually in a good place in many ways. We have an abundance of hydrometric data in the UK, and it's also accessible in the sense that there are these publications that are put out fairly routinely. But what do all these things have in common? Well, they're all very static. These are all sort of paper-based reports. I mean, they're not literally paper. When I started my job in 2001 at CH, we were sending these out in envelopes. It's not literally paper-based, but these are static PDF documents that are produced each month to illustrate where we are. As you can see a map here looking at river flow status, showing these colourful maps where we are now in a long-term historical context. So these are all very static. They don't allow users to actually drill down into the information in detail. They present a pre-selected set of graphs and maps and don't really allow people to explore what's going on in their local catchment or on their local farm scale, for example. So I'm going to be talking for the rest of this talk about the sort of innovations that have been developed over the last few years to go from this more static-based monitoring and early warning to something far more dynamic, far more interactive, and also real time. I just wanted to pause as well and just to highlight the issues with one of the challenges around drought, of course, is that drought means different things to different people. And this has been talked about for many years in the academic literature around what do we mean by drought? And we can recognize many different types of drought, if you like, ranging from meteorological drought, which is ultimately the source of a drought, some rainfall deficit or very high temperatures. But then that propagates through the hydrological cycle, leading to agricultural drought in terms of dry soils, hydrological droughts in terms of low flows, and then impacts on the environment and society. So as a result, there are many different definitions and indicators used. Freya showed one sort of index used to capture drought, but there are many. And before we embarked on all the developments in drought monitoring and early warning that I'll speak about in a moment, we did engage a lot of different users. Going back 5 years or so, we had a number of workshops where we had a whole range of different potential users in the room. And there's a long story to this slide, and I'm not going to go into it all in detail, but there is a paper here that tells this story. But I think the one thing I wanted to highlight was that recognizing that complexity around types of drought, as well as meteorological and hydrological and so on, people talked about, well, what about whiskey droughts, salmon droughts, navigational droughts? And I guess we could add the sort of conditions that lead to blight being into this mix as well. The point being, our colleagues in Scotland talking about whiskey droughts, what they mean by that is there's a certain set of meteorological and hydrological conditions in terms of seasonality and duration and so on that lead to impacts on particular sectors. So in effect, people need different ways of characterizing drought that's relevant for their systems and impacts. But at the same time, they also strive for consistent messaging, which everyone said is really important in communicating in drought to the public and to many different users. So we try to bear all this in mind, and what I'm going to talk to you about, the new portal that we've developed, really seeks to try and allow people that flexibility to define drought and characterize status in the ways that are relevant to them, whilst also ensuring consistent messaging by being based on the same fundamental meteorological and hydrological data sets. So in this part of the talk, I'm going to talk about tools for situation monitoring. And what we mean by that is, where are we now? What is the current status in terms of tracking current water availability? And to really cut to the chase, this is what I wanted to introduce in terms of our new systems and tools for monitoring the current situation. This is the UK Water Resources Portal that was released in March this year. So what is this? Well, fundamentally, this is to try and, as I said earlier on, to go beyond those paper-based systems. This is a web-based tool for looking at the current situation. It brings together a whole host of hydrological data sets and meteorological data sets I'll introduce in a moment. But fundamentally, it's about allowing people to explore these data, to drill down into a mapping interface, click on dots that show the current status, and you can then bring up hydrographs that show how that status compares to the past. So this is very interactive. It allows mapping and dynamic time series exploration. It's real time. Some of these data sets, as I'll say in a moment, are updated daily. Crucially as well, it allows users to present all of that data in lots of different ways. And we engaged with many different users to work out how they wanted to present things. So there's lots of options for exploring different timescales, different ways of presenting the data. Just to show what's on screen at the moment, these graphs are showing things using the same presentation as the EA's water situation reports. And all users felt that was really important because that's the sort of bread and butter of drought communication at the moment. So that's emulating what's done in the EA's water situation reports. Another example though, users are very keen to sort of have a way of looking at where we are now compared to current drought episodes. So here's an example. This is all showing the spring of this year, how exceptional things were. And this is showing how 2020 ranks compared to other major drought events like 1976 or 1997 in this particular part of the world. So it's a way of exploring both where you are now in terms of historical percentiles and extremes, but also against specific hydrological events. And these were all, these kind of requirements were all fed in by users and we responded to them. So what is on the portal? So we have rainfall, river flows, groundwater and soil moisture. And some of these data sets go back a very long way. So rainfall from the Met Office going back to the 1890s. So really allowing you not just to explore the current situation, but really exploring these long-term data sets back into the Victorian era, which is really quite astonishing, allowing you to be able to map all of this data and explore it on a screen. The river flows as well is daily real-time updated from the Environment Agency, and we also get the data from the other measuring authorities around the UK. So this is a truly UK-wide tool. We get groundwater levels from the British Geological Survey, and soil moisture is provided through our own Cosmos observatory that I'll mention briefly in a moment. The point here is there's an astonishing amount of data on the portal, both that's available now and also all this historic data. You can see there's lots of different spatial and temporal resolutions available. So there's an enormous amount of pre-processing done automatically so that users, so that you'd effectively, all that pre-processing is done so you don't have to. You could just explore all the data very visually. So just to say a couple of things in terms of how this has been made possible. Certainly with I think just something really worth flagging is that this daily available river flow data from the Environment Agency is a real step forwards, a sea change in terms of how data is made accessible in the UK. They have essentially an API, so a programming interface that allows you to access their daily river flow data. And we actually make this available on the National River Flow Archive website, as well as on this Water Resources portal. So a huge thanks to the Environment Agency and a big recognition of their efforts in making all of that data available so that we can scoop it up and serve it up automatically in this portal. Another big innovation, CEH has invested in a big observatory of soil moisture monitoring sites. So this is the Cosmos UK network. This is, again, a really big technological step forwards in monitoring soil moisture. It doesn't measure just soil moisture in a tube, it measures soil moisture on a large field scale. And it's incredible, using cosmic rays from space. I mean, by what witchcraft it works, don't ask me. It's an incredible bit of physics going on, but essentially that is monitoring soil moisture every 15 minutes at these 50 locations around the UK. And again, because that's real time, we'll be able to scoop it up and bring it into the portal. So we have real-time interactive river flows and soil moisture. And why is that so important? Well, on this slide here, again, I've shown an example of a couple of catchments looking at recent variability, and you can see the sort of drought conditions over the last few years. But this quote here from Paul Hammett from the NFU, who we've been working with a lot, I think really summarises why we think and we hope this is so powerful for users. It allows people to look at water availability on a genuinely localised scale, for local catchments on a daily basis. And that is, I think, a really big innovation, not just trying to say that in a self-congratulatory way, but just to make that point that this is for a big user community, a big step forwards in terms of being able to track soil moisture and river flow status on a really fine scale. And that's, of course, really relevant from the point of view of the irrigated agricultural sector, to be able to look at water availability in a local catchment. And we'll return to that towards the end of this presentation. And also, just to highlight from my point of view, another key thing about this is it's a one-stop shop for hydrological monitoring. There's an example here on screen showing how I've layered up catchment rainfall, river flows, groundwater, and cosmos soil moisture all on the same plot. And you can do this yourself. Really, it's a very easy point and click interface. And again, without just trying to give ourselves a big pat on the back, why is this such a big thing? Well, I think it's worth highlighting how much computation is going on here. When I started 18 years ago at CEH, trying to actually even compute daily catchment rainfalls is quite a big scientific endeavour. Actually getting all of this stuff done in real time on the fly relies on an enormous amount of computing architecture. As I say, bringing together all these data streams from all these different providers and serving it all up automatically in an interface that everyone can access freely. I think from the point of view of just being able to make all this hydrological data accessible, I think that's a really big step forwards in terms of water management during drought and flood episodes for the UK. So in the last bit of this talk, I'm then going to talk a bit about forecasting. So we've already said, like, monitoring is where are we now and how does that compare to the past? But I'm sure for many people on this call, you have a very good idea of where we are now with your own monitoring on a local scale. And maybe the portal is just more useful for getting a big picture. But certainly everyone is interested in forecasting. It's all very well knowing what the current status is, but can we project water availability over the next season and beyond? You've already heard that meteorological seasonal forecasts are available for the UK. The Met Office, they released these forecasts based on their climate modelling, their seasonal climate modelling, producing these ensemble projections of what's likely to happen over the coming 3 months. This is an example from the current one that's just been released with a nice new format showing projections for the winter ahead. And these histograms are showing this shift towards the mild and wet conditions likely over the coming winter. So this is great to have this seasonal ensemble projection service from the Met Office. I think Freya already outlined why you need these big ensembles. You can't just have one answer because of the uncertainty and variability in the climate system. So they already produced these seasonal forecasts to give an idea of what the weather, the seasonal climate might be like over the coming few months. So within CEH, we work with the Met Office and a whole range of other providers and modelling teams to produce the UK Hydrological Outlook. Hopefully some of you on this have seen this before, but if you haven't, I'd invite you to have a look. The outlook for the winter will be published on Monday, looking for the next 3 months and beyond. But this does provide UK-wide seasonal forecasts of water availability. So that's both river flows and groundwater. Using a whole range of methods, we take those Met Office seasonal forecasts and we run them through our hydrological models at CEH and groundwater models at BGS. So that is all available, providing projections for the coming months. It's fair to say, though, again, these are static at the moment. They produce nice pre-formatted, colourful maps, but you can't actually get at the local scale forecasts yet. However, we've been working over the last few years as part of a big droughts project we've been working on, funded by NERC, with making these outlooks available on a catchment scale. I won't go into detail on the methods, and this is a very complex plot that I'm not going to sort of unpack in detail. The main point, really, I want to make, this is from last May during the very dry conditions. The main point, of course, is that we're providing projections of river flows over the coming, not just the coming 3 months, but actually over the coming year. This diagram at the bottom, where it's showing all these orange colours, that's really showing the likelihood of dry, low flows continuing over the coming months, essentially. And these are all available now. We don't release these on the Hydrological Outlook's website at the moment, but they are available every month in the first few days. And if anyone's interested in receiving these to see how they might use them, then please do let me know. But what have we been doing with that? Well, as I say, we've been opening up these forecasts to make them available on a catchment scale through this droughts project. We've been sharing them with a very wide range of users, and there's a number of organisations shown here, to try and understand how these could be used in practice. And I'm going to give an example now from the water industry, but I think this is actually just as relevant for the agricultural sector. And this is an example where we worked with Yorkshire Water at the tail end of the 2018 droughts, looking into 2019, where in Yorkshire there were still concerns going into the winter. And Yorkshire Water wanted to know the likelihood of reaching certain hands-off flow conditions over various time horizons. So we took the same forecast that I've shown a moment ago and that are produced routinely and operationally, and just produced a bespoke visualization that allows Yorkshire Water to see the likelihood over the next 1 to 6 months and beyond of actually reaching a number of different hands-off flow conditions. And this was felt by the company to be really useful in giving them a heads up on the likelihood of reaching those HOFs over a range of timeframes. We also last year worked with the agricultural sector in a workshop within FU and AHDB to see how this same kind of approach of looking at the likelihood of HOFs or other flow restrictions over the coming months would potentially be very useful for that sector. I think it's fair to say, though, we're only really just beginning on that journey with the agricultural sector. We've done some worked examples on some individual catchments, but we haven't got the long-term engagement that we've had in this example with Yorkshire Water. So if anyone's keen on using these forecasts in a sort of on a trial basis and seeing how they could be used on a local scale for an actual applied application in an irrigated catchment, for example, then we'd be really, really keen to work with anyone who may be keen to do so. So I'm just going to finish now, the last couple of slides, and I couldn't really get away with not giving a view for the coming winter, I guess, sitting as we do in early December and knowing how crucial the winter is for recharge and replenishment around the UK. And these are a couple of the forecasts that are going into the hydrological outlook that will be released on Monday. So this is very much a sneak preview. The main point here, I'm not going to go into detail, but this is showing around the country a propensity towards either normal flows or above normal flows. So there's certainly no indication of there being any concern towards dry weather or drought conditions at this stage. The winter, if anything, is looking like it's going to be wet, it's going to be higher river flows, and so perhaps more of a concern around flooding. Of course, we've got to unpack that on a very local scale, and this shows, again, showing how the portal is able to show for an individual catchment here in East Anglia and the wider region that the current flows, again, are very much above normal. So, and this is a chalk catchment where flows are quite high at the moment and are likely to continue being high going through the winter. And this plot, again, all I want to draw your attention to is the fact that these blue and green bars are showing really normal or high flow conditions really going through the winter and into next spring. So obviously this can change, and the arid spring we saw last year, the weather is very capricious and can change very much. But based on where we are now in terms of hydrological storage, we certainly expect to see generally good prospects for going into, where we are going into the winter, good prospects for going into 2021. So I'm just going to finish with I'm going to have a summary now and just highlight a couple of other ways this is moving forward. So in terms of future directions, just to highlight a couple of other things that are in development. Of course, there's a massive amount of data on the portal, as I've said many times already, but it is inevitably limited where you have observations, and many people want information where we don't have river flows measured or soil moisture measured. Of course, there are other possibilities, and we've been working on using Earth observation and model outputs to provide forecasts or provide, situation monitoring everywhere, including where we don't have any observations. And this graph is showing a soil moisture product based on satellite and model observations, which we're about to release. And when it's made real time, is something that we will include on the portal to start giving observations of soil moisture everywhere, not just at the 50 places we have Cosmos sensors. And again, this is just an example of the many different things you can do with the portal. We've been working with the EA to bring water quality data and ecological data into this framework too. So the vision, if you like, for agriculture, I've seen there's already a question about how the potato growers can use and benefit from this. Well, I would say we already have this seamless access to real-time hydrometric data, but what's certainly becoming more possible now is dynamic access to these catchment scale forecasts. And I would really like us, first of all, to be able to work with users to understand how they can use these projections of potential hands-off flows or other irrigation restriction potential going forwards, to try and allow some customization of these sorts of tools for agriculture. We are working on an accessible portal for the hydrological outlooks that will be available in next year, and that will allow users to actually look at the likelihood of reaching any flow threshold over the coming months, whether that's a hands-off flow, Q95, or anything that you might be interested in. So that is becoming available, and it will be. You will be able to get at those outlooks as well as just the situation data. But in the meantime, if you're interested in receiving these forecasts, then do let me know. But we certainly see the potential as well to link this up with all of the license trading information that is available that is increasingly available from the EA. They've got this license trading application that gives one way of potentially bringing our hydrological information alongside those license information in future. So that's certainly our vision of bringing all this together. We've already got a sort of very system that tries to speak to all users at the moment, but I think there's potential for building more bespoke add-ons and modules, if you like, or apps that are relevant for agriculture. And as a final sign-off, again, this is just a call to arms, really, that I think there's lots of potential being able to use more mobile applications, mobile versions of this portal to actually bring data back in using more citizen science approaches as well. And finally, we're aware that there's also a ton of monitoring that goes on a farm scale. And again, could we potentially assimilate those kind of local scale observations into these broader scale data sets we have on the portal? Okay, so I'm going to finish there. Sorry, slightly over time, but yeah, so thanks very much. And if you do have if you are interested in doing any collaboration on these demos or how these things might be used in your situation, please do let me know. Thank you.
Okay, great. Thanks, Jamie, and thanks to Freya for giving us an insight into your fascinating work. Now, we've got lots of questions that have come in. We've got Freya back. I'm just going to start with some questions for Freya on the climate change projections and seasonality. So we've heard that when the ice caps have melted, the Gulf Stream will weaken. Will that take away our mild winters?
So the thing is, although it is potentially a very serious situation if the Atlantic meridional overturning circulation, so that circulation in the oceans, were to shut down because of a lot of fresh inputs into the Atlantic Ocean, we actually think it is very unlikely to happen this century. So although changes in the oceans might cause a bit of a weakening, which might bring less warm ocean water up towards the UK, any impact on this would still be not enough to cancel out the warming from climate change, as it were. So it might weaken slightly the amount, it might, so it's not going to cool us, but we might have slightly less warming. So we will still see mild and wetter winters. And the way that the atmospheric system works, you're still going to be having the atmosphere and as well as the ocean bringing a lot of heat up towards the UK, regardless of if there is that weakening to the Gulf Stream.
Okay, great, thank you. We've got a few on seasonality. Just find this one. We always are talking about this, how the seasons will change, but it seems like we're getting more extreme events out of season, such as the very wet August in 2020 or September last year. Is there any way of knowing how this will change over the next decades?
So what we're seeing is against this sort of backdrop of a trend, these increases of extreme events. So that's what we're saying. But of course, it's hard to predict if and when you're going to get an extreme. So that is obviously seasonal to decadal modelers are looking really hard at those forecasts Jamie was talking about, so that we can do a better job, of predicting, next season, next year, to try and get those extreme events. So it's possible, but yeah, you've got to be prepared for both the sort of the warming trends, but also the extremes and differences, and we all know the UK climate is very variable. It always has been, so we're looking at that variability superimposed over a trend, which makes it a hard job to predict.
Okay, thank you. I think got two similar questions here. I'll just take this one. Do the projections become more severe if they are taken as the potato growing season, i.e. March to September, as opposed to the annual projections?
So because of the Hutton criteria being 2 days consecutively where the minimum temperature is over 10 degrees Celsius, that is not an event that you see at sort of a minimum temperature is what you're getting, in the middle of the night. And that is not going to be over 10 degrees mostly in the winter. So there isn't really much difference, I think. The only thing I was thinking at this is if you are getting sort of, if you might get those conditions in the winter due to maybe using a different temperature threshold that might be lower. So, but I think, I think, Siobhan Dunst did this work getting this Hutton criterion. It seems that 10 degrees is the best predictor for when potato blight occurred. So I don't think there'd be very much difference. So I did do a little bit of sensitivity analysis looking at this when I first did the research, and yeah, it's not something that you're likely to worry too much about.
Okay, great. And one related to that, Freya, you said that summers will be hotter and drier. How does this lead to more incidents of Hutton criteria? In hot weather like June this year, we have little blight.
So because it's about timescales, I think, you see. So although overall your summer, or your month might be hot and dry, you're still going to see these intense summer bursts of rainfall, or spring or autumn. And when you get these intense bursts of rainfall, then that is making these higher humid conditions for a short time scale. So your overall, the month on average, it's lower, but just for those shorter periods, you're getting the conditions satisfied because you've got that higher temperature plus the humidity. Yeah. Thanks.
Okay. One, we'll start off with Freya, and then maybe Jamie might want to come into this one. Is it valuable for potato growers to have little met stations in their own fields? These are strongly promoted by the company selling them. Perhaps Jamie, you might want to contribute about in-field monitoring.
Yeah, well, I guess I mean, I think it's always a question of scale, and of course, those the sorts of things that we are providing on the portal, where we take the Met Office rainfall, for example, we do have a 1 kilometre gridded data set we serve up through the portal. So there is, it can be relatively fine scale, but because it's trying to provide that provision across the whole of the country and give the interactivity, it clearly doesn't go down to field scale. So to get those, of course, the micro scale observations, there's a need for those as well, I imagine. Not being an agronomist, but I can certainly see the utility of those given the variability, spatial variability we do see in meteorological variables. Having said that, although I think there's a distinction between these scales, there's also lots of potential for some overlap. And I think I highlighted that in my last slide, that one of the big things we see lots of potential in is trying to make more of these sort of technological setups that people have in their on a field scale. We've already done some pilot work with assimilating some of these more informal observations. Some other people in CH have been doing that, looking at soil moisture, and I think there's a lot of benefit in that, because it is horses for courses. Obviously, that the nature of the instrumentation is different depending on the scales you're looking at. So I think that even these larger scale national systems for real-time situation tracking or forecasting potentially could make more use of those observations, because, as I said, we don't have observations everywhere. We tend to use Earth observations or modelling to fill in the gaps, but to ground truth that, you need some field scale observation to do that. And I think that's where some of these fine scale observations could be really useful. So although there are distinct scales for the different purposes, I see that there's benefit looking up and down that chain and seeing where they can be assimilated.
Yeah, so I was going to say, I also agree that, and maybe that information at farm scale might be useful to you. For example, if you then compared over a period of time to the local forecast, and you found, well, actually my field's always a little bit more sheltered for some reasons, it's always a little bit more warmer, then you'll be able to sort of do that adjustment in your head. But it's not going to help you for long-term prediction. But if you're going to get an automatic weather station and feed in that data, so I was going to mention the Met Office weather observation website, which allows people to feed in that data, but also see your neighbour's weather station as well if they've got one, so you can go and have a look there as well. So thanks.
Thank you. One for Freya again. You're talking about late blight, but Alternaria likes hotter weather. I don't know whether you've looked into early blight. So Alternaria likes hotter weather with intermittent rain. Have you looked at Alternaria?
I haven't. So it's always true that some, in some cases, some things will do a little bit better under warming. So maybe that's something that's worth looking at a little bit more.
Okay. I think this may be more one for Jamie, and you might have answered this a bit already in terms of in-field monitoring. Is it not time to work with growers to provide infrastructure for managing extremes, e.g. grants for reservoirs and more flexibility in abstraction licenses?
Yeah, I think all of those things, from certainly a lot of the engagement we've been doing with NFU and AHDB and individual farmers and growers in a lot of the workshops we've done as part of this NERC-funded drought and water scarcity programme, have really highlighted all those, the potential benefits of those sorts of adaptations. And I think it's clear that a lot of those things are, there is a lot of investment in the reservoir construction. There's been some part of the droughts and water scarcity programme I was involved in with some work from the Cranfield, providing tools to actually enable sort of reservoir planning and sizing to be done. And similarly on the flexible abstraction side, there's already been many advances in that area. I think what's key though is that those sorts of things are all needed. But the sorts of things I've been presenting, and this is not just the work we do at UKCH, but in our collaborations with the Environment Agency and others, they kind of rely on these better observations or more accessible observations. So I think those sorts of adaptations it's recognised that they are what the benefits are of those. But it's quite challenging, especially around the abstractions, licensing and trading. When you think of the sorts of, I hope I've conveyed that there's been big steps forwards in actually providing the hydrological observations, but when you're dealing then with another layer of complexity around all of the licensing information, there's a lot that needs to happen to sort of make all of that readily available and interpretable on a local scale. But I definitely think that it's recognised by the sector and by the regulators and others that those things are needed. There are steps in that direction towards supporting the sorts of tools that are needed, both with creating more storage and also with providing mechanisms for more for flexible abstraction licensing and local scale trading and so on.
Okay, thank you. Another one for you, Jamie. I think you touched upon this towards the end of your presentation. How can the potato grower use and gain benefit from this tool?
Yeah, so I saw that one pop up, and I hope I sort of went some way towards answering that, in the sense that I think you can answer on two levels. Simply knowing local scale water resources status, I think, is potentially useful for farmers and growers in general, in the sense that you've got more of a picture of what the local sort of water situation is, what it's like, and how it fits into the wider regional and national scale picture, and also then how it might change over the coming months. But I think where we've tried to go beyond that with the work we've done on the forecasting, by looking at the likelihood of reaching hands-off flows or other thresholds, for example, is a very specific example of how you can take these kind of forecasts and look at the probabilities of reaching a threshold that's meaningful for you. And obviously in a local catchment where presumably if you have abstraction licenses for irrigation, then knowing the potential for restrictions in the coming season or beyond is the kind of thing that we're trying to get towards. And certainly the example we had with Yorkshire Water, where we looked at the probability of hands-off flows, we did a similar thing, I should say, as well for SEPA, looking at the likelihood of low flow conditions that are relevant for the environment, so Q95, and how long will be below Q95 in the coming summer. These are all examples of how the forecasts are not just some abstract way of looking at overall, water availability in the east of England. It is something that really, on a catchment by catchment scale, you can start to look towards the likelihood of reaching some given meaningful threshold in the coming season.
Right, and I think what you just said relates to this question. So what information is currently available from CH to the farmer and grower? It sounded as if some good things are coming out, but not yet.
Well, as I say, all of this information is available. It's all freely available to anyone. So I think it's all the portal as it stands at the moment, and the hydrological outlooks that we produce in collaboration with many others. They're all available now. But in terms of what I touched towards at the end of the presentation, making it more bespoke for agriculture, I think we've only really just started on that journey. So a lot of the work we've done over the last few years with the umbrella organisations and with some partners in the sector. But I really see that's something we want to work on more, to be honest. So taking these, as I say, all the portal and the forecasts speak to all users, companies, regulators, navigation, and so on. But there's so much potential for providing bespoke add-ons for agriculture. And I really think that's something we want to invest in further, to take these things and translate it more towards the particular metrics and things that are actually really relevant for the sector as a whole.
And you're inviting people to come forward and trial that.
Yeah, absolutely. Yeah, as I say, we've done the work we've done so far has been more in more general sort of workshop spaces, but the kind of thing we've done with Yorkshire Water, which was a long-term provision of those forecasts over a couple of years to see how they could be used and reformatted and made more bespoke, we'd be really keen to look at the options for doing that kind of thing for the irrigated sector, or indeed other parts of agriculture, if there are people who are keen.
Yeah, so if anyone's interested, please contact Jamie. Or contact me, I can pass the details on. Yeah. We've got another question for you, Jamie, related to what you said about sensors. So potato growers spend a fortune on sensors for soil moisture deficits. Could that be incorporated into the CH data to give a bigger coverage? If yes, how could that be done?
Yeah, I mean, I sort of touched on this earlier on in general about meteorological observations. I strayed into soil moisture, but I absolutely think this soil moisture is one of the things that it is not routinely monitored. Generally, it's estimated from all sorts of models and so on, at least at the national scale. The Cosmos Observatory has been a big step towards having a set of observations, but there's only 50 of them. So if we want to ground truth Earth observations, if we want to ground truth model-based soil moisture, we need observations in the field. Cosmos has been a brilliant step forward in providing ground truth, but it's limited in what the amount of sites there are, and they cost a lot of money to put in. Where there are already observations available at the farm scale, I'd be really interested in looking at trials of how we could potentially sort of assimilate those kind of things and use them for validation or integration in some of the broader scale products that we produce.
Great. Thank you. And one last question for Freya. In eastern Scotland, there are many opportunities for irrigation from rivers coming from well-watered highlands. When you predicted more drought for this, were you taking these opportunities into account?
So the drought metric that I showed was rainfall deficit. So yes, to some extent that would be, you know, including the water falling on the highlands. And I think what the models seem to be projecting is that there's less chance of drought and more wet rainfall on the west coast of Scotland. So I think, you know, physically warmer air holds more water, and perhaps then as you've got this super saturated air and it's pushed up over the mountains from the west, then it's going to fall more on the west coast, and so less is getting over to the east than in the future than we see at the moment. So I think there is still, you know, it's still, you know, it is something to be concerned about, because you might have all that water in West Scotland. So, you know, Scottish water authorities may be thinking of how they can put reservoirs in the right place or transport water to get that water from the west coast to the east coast. So I'm sure there's mechanisms for adaptation that can help transport that water, because certainly we're still going to see a lot of rain in West Scotland. It's just getting it to that east coast, which might be quite dry.
Okay, thank you very much. I think that's the end of the questions. So I'd like to thank Freya and Jamie again for their time today. I think it's been a fascinating insight into Freya setting the scenes of climate change projections, look at the challenges for growers, particularly in the potato sector in terms of late blight and drought, and the possible adaptations that we might have to look at, and also touching upon the implications for irrigation as well. And also Jamie looking at the resources and tools that which are available now at the catchment level. So I think that's really interesting insight that we've had today. And thank you for answering those questions so thoroughly as well.
Thank you.
So that's the end of our second webinar today. I'd like to thank you all for joining. I'd like you to scroll down the session window to complete the feedback form. It's really important that we can continue to improve, so your feedback is really valuable. You see in front of you that there's Basis and Norozo codes, so you can sign up and get those points. If you want to quickly scribble down the codes, or just take a quick screen grab, or go back, revisit the presentation, which will be available later on. Please join us in the next Agronomy Week webinar, which will start at 2 o'clock. And enjoy the rest of your day. Thank you very much for joining us.